Recording. 1 o'clock. 1 o'clock. We'll get started here. Oh, there's Zach. All right. All right. We'll get going here then.
What's going on, Stevie?
What do we got? So today we start day 11. We're getting down to we got 3 more weeks officially left, I guess. Um, I should have everything. Everything's graded except one thing. I haven't. I'll get through the service entrance sheets probably tonight and tomorrow. You'll see the grades getting posted there. I gotta say, it's a. I'm not gonna hold everything against you. Really, I'm just gonna make sure your calculations are right based on your square footage and all that kind of stuff. So, but I should have those grades getting posted up coming up real either like I say tonight or tomorrow.
Yeah, I really want to see how I did on that one.
Uh, I've never, I never have a failure on that one. It's like I say, it's really if your square footage is off or something like that, but then based on your calculations will really be what your grade is, not if every answer is dead on right. but uh, but yeah, I'll have those posted up over, like to say tonight and tomorrow. And those will be all caught up, and then. I think other than that, you guys have we got the homework due on Thursday, and then there's a chapter 7 quiz that'll be due on Thursday, and I think let's see, yeah, that's what we'll have posted for today. So yeah, chapter 7 quiz, and then chapters 15, 19, and 23, I think it is. And today we're going to review chapters 15 and 19. Kind of, I don't know, in a way they're easier chapters. It's talking about like special utility outlets and appliance hookups, that kind of thing. One thing we'll start, so today we'll talk about chapters 15 and 19, and then the next meeting we'll finish that up with chapter 23. The first thing we'll talk about is, and this one's becoming more and more popular now, is they're actually becoming more and more efficient. It used to be that the electric water heater was not very efficient compared to like the gas style one, but they've been making a lot of headway and different things with the electric, and they even have like the on-demand style now, where you don't even have like a tank, if you will. You just have something mounted on the wall that delivers hot water on demand. But yeah, the typical wattage ratings they have from these things can be as low as 1500 and then go up to 5500. They might even have some larger ones these days. But what they'll do is they use like a heating element or heating elements to raise up the water temperature. And that's either the on-demand style or with this, the traditional tank style. And you can see they'll have like an upper and lower filament. And these things range, it depends on the company that makes them. They range in like their sizes and styles, but when you really get down to it, really all it has in there is some kind of heating elements or some kind of weird alloy or something like that. And basically it just delivers electricity to it instead of doing like the gas firing. And the reason we talk about these, of course, it's like because the power demand on these is a lot higher than you would have like on a gas fired one, of course, because the gas fired all you'd have is the little electronic ignition. Whereas this one, you actually have a full heating element. And you've seen the power demand on that thing, and of course, it'll have to be hardwired, and there's no like plug style to it, if you will. These things all have their own dedicated circuit and whatnot, and you treat it just like any other large appliance. And there's a couple examples of the heating element styles. You can see they vary in like thickness and the way they're done, and it's up to the manufacturer and how they designed it through. I mean, they all do the same job, right? heat water. And this will be the typical style heater control to it, which will be a little bit more robust. It's like a more of a heavy duty style. And what this will do is like a switch operation to turn the elements on and off as needed. So they do have some safety things built into them. These things will not get over 120 degrees, so it's not like, you know, boiling temperatures. And yeah, these are large appliances, so they're going to have the two hot lines to them. So you have a 240 volt circuit to it. And it does have combinational controls that'll regulate the temperature of the water, and they're settable. You know, it depends on the style you got and whatnot. Some of them might actually be even digitally programmed. Some of them will just be straight manual, turning the knob settings kind of style setup. And again, it all depends on what you bought. And the way they treat these now, the electric water heater is considered what, a continuous load. So that's like the motors, if you will. So when you rate these things, you'd have to take the nameplate rating of the current and multiply it by 125% to come up with your breaker size. So if this thing was, well, here we'll take a little look at it. So depending on the size of it, you know, you'd have to, that would be what your overcurrent device is, you know, your fuses or your circuit breaker or both, depending. They are rated at 240 volts. And the heating element will only produce the rated wattage as it's supposed to, you know, again, depending on what you purchased. So if it's 1500 watts, it's 1500, or if it's 5000 watts, it's 5000, that type of thing. So we always use the rated voltage. So in this case, what, 240 volts to calculate what our resistance is, how much current we're going to pull, and what the overall wattage is going to be of the resistive heating element. And the way we do it, it's a simple application where we say current is equal to power divided by the voltage, right? So they're considered a continuous load, meaning we have to do the 125% rating. And this particular one we had, let's say it's 5,600 watts. We have the 240 volts. So to find out what our current size would be, right, we would do this straightforward and we come up with that this thing's rated at 23.33 amps. And then we go through and multiply it by the 125%, right, to get our actual size. And then we come up with 29.2 amps. So we would have a 30 amp breaker and be using a number 10 style wire, number 10 AWG. 30 amp would work fine. You see, if we went less than that, while this thing is running, of course, we would end up tripping the fuse a lot. So, but that's how you go through it. Treat it the same as a motor because it's a continuous cycle. The thing is on a lot. So it would be on more than, like, you know, typically 3 hours in a day. So that's why we would have to treat it like this. So if you had two elements, right, or they're running at 4,200 watts each, how much current would they draw? So this way we'd figure out, well, let's see. So we get our 35 amps based on the 240 volts, right? And we see that we come up with a 43.75 as our current draw overall. And then of course, calculate it through just the same as we did previously. And so what size wire do we need for this? In this case, this one's a little larger than what we did previously, even the breaker size, right? So we're going to pull number 8 wire on this guy with overcurrent, you know, 43.75. So we would probably be putting in like a 50 amp breaker for this thing, something along those lines. But, and then we look at the ranges and ovens. And now these can be in two different styles. They could have where they're hardwired in directly to the box, or they have like a plug style cord to them. Now, if you have a freestanding one, right, when it's able to get moved, so you'll have either like a flexible whip, okay, you know, the bendable style where you have wire running through it, where it's actually attached to the wall, in which case you don't have any way of unplugging it or plugging it in. You would literally have to disconnect the wires from the service box. Otherwise, you'd go with a plug style, where and it would be a special type actually. Um, and it states, okay, that we cannot have less than 40 amps for ranges that run in this range. They do have lower ranges for that, and these are considered drier cords. But yeah, for the ranges and ovens, you can see it's a little bit more of a power, the heating element involved and whatnot, and how long they're expected to run and everything involved with that. But the cords come, yeah, you would have a cord set and you would install it onto the oven, and then it would just be a plug-in style, and they're funny looking. You can't plug in like your normal two-prong spades to them, if you will. But typically what we run in, it's like they have cord sets and you purchase these separately, right? So when you do buy your appliance, always make sure you get the cord with it. Otherwise, when you get everything home, you won't have any way of attaching it to the power. But typically they run in 40, 45s, and 50s. And you'll notice that they set the 30 amp ones as usually considered too low for like a range or an oven. And those are considered dryer receptacles. Okay, and then the 50 amp ones are known as range receptacles. So when you do purchase it, you just match up your given appliance and make sure you get the proper cord to it. The cord sets are basically identical. I mean, as far as like the prong layout and whatnot, unless you looked at the actual rating, you wouldn't be able to tell at a glance that one is rated for 30 and one is rated for 50. That would be something you would definitely have to look into and make sure you do apply the proper one. They do, and then the 30, 40s, and 50 amp styles, they're in what they call a 3-pole, 3 or 4 wire configuration. We'll take a look at some of those. So we see 4 different styles here. You'll notice here's on the left-hand side, we see 2 50 amp styles, 3-prong or the 4-prong, right? 3 or 4 pole. There's 3 wires to this or 4 wires to this. Now, the extreme left over here, that was a prior to 1996 NEC. If you were to do any new installations, you are supposed to use the 4-prong style. But you still see a lot of these out there as far as the setup. If that's how your house is wired, then that's the type you would buy when you would hook up. Let's say if you bought a new dryer or something like that, that would be the style you'd buy, or you would buy this style. And when we look, you'll see it's a little bit different, right? On the 30 amp styles, you'll notice that we have this little L shape to the ground plug versus this one. And even on the 4-pole style, you notice we have a little L prong on there versus this one. And these are different plug styles, so you can't mix and match, like you can't plug the 30 into the 50 and vice versa. So your prongs would actually be a little different. Don't try to force it and jam it in or anything like that, basically. So as these ones on the left, that would be considered your range style, right? Your cooking range. And then the ones all the way on the right, that's your dryer style. So, and like I say, they look virtually identical except for the one little prong difference. And that's so you don't mix and match and, plug a 30 into a 50 or a 50 into a 30, you get the wrong draw and end up frying out some equipment or something like that. Nobody likes that. Now, if you open these things up, usually you have to wire them. Okay, and so when you open them up, where you have to put the wires they're actually labeled specially, where X and Y are considered for because you're going to have 240 volts, so you'll have 2 hot lines, and that's for those X and Y. They'll have a W marking, and that's for the white, or what's considered like the neutral, and then they have one for green for ground. And that's if you have the 4-prong style, which of course after 1996, so any new installation would require this kind of setup right here. And that's pretty universal. Every marking that you'll have, you'll see an X and a Y for the plug style setups. So when you actually go to wire these things in, you'll notice when you're installing that they're actually marked properly like that. And they even have like different screw colors to these. Like X and Y will be like a golden or a brass color to it. The W will be a silver, and the green screw, of course, will be green for ground. But that would be the way they would have the four prongs lined up for you. So they try to make it so it's hard to misinstall. It can still happen. So, and a lot of times though, when you have like a fixed style where you have a wall mounted or built in like oven or, countertop style cooking units, um, usually you don't have a plug for those styles. Generally they'll be hardwired in. You'll have a junction box available for those. So you would run like a flexible whip from the box to the actual appliance itself, and it'll have like a little service appliance box, utility box, probably with a knockout, so you would attach your connector and the whip going down to your junction box, and it would be hardwired up. You would have no plug or anything like that. So if you are to change out the unit or move the unit or anything like that, you will have to manually disconnect it, turn off your power and whatnot. Now, clothes dryers, and they can be in a few different styles, depending on what you buy. But they can come in either a 120 or a 240 volt style, single phase, 3 wires, right? Branch circuit, dedicated, um, flexible connections. So you can move your appliance out and service it properly. So when you do the whips to these things, you want to make sure you have a fair amount of play to it so you could pull the dryer out and away so it can be moved for whatever reason, or for servicing or cleaning or whatnot. So you don't want to just have it like real tight whip to it so you have no flexibility to it at all. And of course you have the cord and plug style as well. So the most common way is usually a 4-wire 30 amp receptacle behind the dryer. Although there are the types where the homeowner decided to go through and just hardwire it through, in which case you would have the whip. So if you really needed to completely disconnect it, or say you bought a new clothes dryer, yeah, you'll have to go through the extra step and disconnect the wiring from the junction box, turn off your breaker and all that good stuff and go through it. So as far as ease goes, it's probably easier to have just a plug and receptacle style, but you will run into these hardwired ones occasionally. It all depends. But you can use a direct connection. You use the armor, sheath cable to the junction box. A lot of people usually will run like a pipe down to the point and then transition to a flexible metal. I'll show you a picture of that. Something a lot like this, where you would have the hard connection up to the actual dryer itself with the whip running out through it, right? And we got the 4-wire style, so 2 hot, so white for neutral, and then a green for ground. And then what you would have is going straight to the EMT, where there's no box style. It's just literally runs straight into this thing. They've got a combination coupling, so it goes from rigid to flexible from both ends. And it's hard to mix and match these because of the sizing involved. So even if you had 1/2-inch EMT with a 1/2-inch whip, the type of coupling end that it has to it, you can't reverse it. They won't fit properly. So, but this side here is considered the rigid or the piped connection style, and this type is usually for the flexible. And that's just how they would have it. You would literally be coupled on, holding the sheath in place so it can't be pulled out or disconnected accidentally. And this would run off somewhere in the crawl space, a junction box somewhere or whatnot. And they have another style, so then you would have just the straight receptacle hooked up down to this, and the dryer would just plug into that with the four-prong style like this. And this one, of course, yeah, that's the most popular. It's probably the easiest one because, the dryer is not going to be forever. So if you do need to change it out the one day, you'll appreciate having this as far as the ease involved. So, and then, of course, how do we size it? So we got to go through and make sure that we size this properly, right? So you have a dryer heating element. Usually, though, you just have this connected up to the two. the two hot wires don't contribute to the current on the neutral, right? That's a different style setup, especially these days where you get the smart dryers and whatnot. So they'll be running stuff on the 120, and whereas the motor and the heating element might be on the 240 line, that kind of thing. See here, yeah, the motor required 120 volts and don't contribute to the neutral. But so if we had a 5,000 like watt rating on the nameplate, that's what we would use for the load calculations. Of course, since we have the 240 volts, that's what we're going to use as our divider, right? So if we have 5,000 with the 240, we could divide those out and figure out, okay, how much current we have. We don't do the 125% with the closed dryers. They're not considered that. And so then we would divide through and find out what standard size breaker style, because this would again be dedicated. So the only device hooking up to this particular branch would be the closed dryer, and that's how it would even be marked in your cabinet. And there's a couple of examples. Two styles of crimp-ons. Now, there's pros and cons to either style, believe it or not. So you have the open prong ones, and these are nice in the fact that when you loosen up the nuts, you can just slide that prong out, if you need to change it out. Now the downside, of course, is what happens. Let's say, remember, this thing's going to be running, right? So you're going to have a certain amount of vibration to it. And given over time, yeah, the nuts probably shouldn't loosen up, but you never know. Things happen. But if the nut loosens up on these open prong styles, this could potentially become disconnected, slide loose or something like that. Whereas now you have this style where it's got a closed end to it. Basically, it's got a circle punched in the middle of that. So if this bolt were ever to become loose, you don't have the danger of this wire falling off or anything like that. Yeah, I mean, when it gets loose, of course, there's going to be sparks going off and whatnot, and that'll probably trip the breaker, and that'd be your indicator that something is going wrong. But but you wouldn't have the added safety benefit of the wire becoming loose. But again, at the downside being that if you do have to change this out, you're going to have to completely take that bolt all the way up versus you don't have to do that on this style. So like I said, pros and cons. It's personal preference more than anything. Your chances of this actually, as long as you got these things torqued down good, your chances of those actually slipping off are pretty low. I mean, yes, there is the possibility, so you can never totally exclude the chance of that. So here's a little creativity, if you will, but it's proper. But you can see that these receptacle styles, they fit into a 2-gang box, okay? But the way that they're built is that this would allow no other type of installation to occur inside of this box. So you literally would have 4 screws involved with this thing to tighten it down. So it will take up the whole box. You can get the style where you're in a single gang box, but because of the size of the wire involved and the size of the receptacle, it's probably better to go with a 2-gang box than anything. But you will see these little gem styles, the single gangs, they are available. You'll see a middle post on these receptacles, so it does allow for one single screw to be mounted in there. But this is the more common style if you have a built-in. This is an add-on for, just basically throwing it in cheapest possible. but that's pretty much, I mean, it today. And here's usually what your basement's going to look like when you go in and install your closed dryer. No, yeah, if you walk into something like this, ooh, it might be time to turn around and walk away. But this was an apartment building. Where they got a little creative. And again, right, violating the rules. Nothing's supposed to be, 36 inches in front of any disconnect. It's supposed to be able to shut all the doors and everything else. Yep. This is a real deal. This was an actual apartment building laid out this way. Smaller apartment, but still, it was, it's an eye opener. And there's your usual typical dryer from Home Depot. No, I think it's a doghouse. I do. But it could be like a chicken coop or something. The things people will do. And even though, it's a regular clothes dryer, you got to remember this thing's pulling at, 30 amps, right? So when things do go loose and they end up shorting out, they will make one hell of a fire. And you can see it burnt this thing through to the point where you, they're supposed to see the one on the right here where it's got that screw mount to it. That's what's supposed to be on the left here too. But you can see it's pretty well gone. But yeah, these 30 amps is 30 amps, and that's some power to play with. So when it does do a cross or an arc, it's gonna go. And it does happen for whatever reason. I mean, hopefully not water or something like that, but yeah, it's always a possibility. But you'll definitely know when these things do go out. But here's a good installation. I mean, nice and clean, right? Good 2-gang box, 4-prong style plug. And the good thing about these, they're good and secure. You can even see, where I was marking out that little L shape to it. So that would not fit in, the 3-prong style. You can force it, but no. But that's usually how those look now. Nice and big, sturdy. So when you do plug it in, the chances of it coming out are pretty minimal. But there's a variety of ways to go ahead and mount these up. But that's a good installation, hard piped all the way up to it, nice and grounded, good and secure. It ain't gonna move. But that's really it for this chapter for today. Like I say, we're going through sizing like special utilities. We're starting to wind down on this on the homeworks and stuff. I do have one more. Let's see, you got the chapter 7 quiz, and then after that, I think the only thing I really have is I have a third uglies quiz coming up at you, and then for the last week, I assign a couple of extra credit projects if you want, or I'll do an uglies book extra credit, and then like a code, sort of like a quiz, not really a quiz, but like a code violation based on the picture involved. So you take a look at it and see if you can identify the violation, and let me know, and then that'll be your extra credit for that. But no, let's see here. Like I say, we'll go through. Yeah, so you see I've got the chapter homework assigned there, chapter 7 quiz. And then, like I say, we'll have on Wednesday, I'll post the third uglies quiz, and have something over the weekend to work on. And then pretty much in this last week coming up here, we'll start doing some review and things like that, go over some of the things we learned. And then I'll give you a kind of like an exercise sheet, if you will, for like a final review. And then I got a full out like cheat sheet, if you will, but like things to know for the final. And usually if you go through and do the little exercises and follow the cheat sheet, you do pretty good on the final. I don't throw any like curveballs or anything like that out there. It's pretty straightforward. I think it's like 50 questions, but yeah, that's really what I have for today for you guys. Like I say, go through and do these upcoming homeworks, the chapters 15, 19, and 23. It's all about appliances and hookups and appliance. So most our calculations will be, you're going to have to figure out like what our current ratings are supposed to be for like the disconnects, right, for the circuit breakers, that kind of thing. Figure out, like I say, like the heating element styles, remember those have to have 125% duty cycle to them versus like the dryer styles where it's just a standard But that'll be about the trickiest we get with the calculations for any of that stuff. But otherwise, yeah, it's all dedicated breakers. You know, the good thing about these branches is there's only the one branch. It's like if if this circuit breaker is feeding the dryer, if this circuit breaker is feeding the range, you know, the oven, that type of thing. And but but yeah, that's pretty much it. And like I say, I'll go over and tonight and tomorrow we should have all the grades posted up for your service entrance worksheets that you guys did. And then that's really about it. Yeah, like I say, we're gonna start winding down, so won't be beating you up with homework or so much anymore. But yeah, that's unless you guys have any questions or anything, or we're doing okay so far. I hope. Oh, it's so quiet.
I ain't got no question.
Huh?
Good.
No, I don't got no question.
Okay. But otherwise, yeah, you guys, looks like everybody survived the 4th of July, right?
Yeah.
Right.
But yeah, I guess I'll see you guys on Wednesday then. Otherwise, yeah, let me know if you have
Okay.
any trouble with any of the homeworks or anything like that, or with that
Okay.
chapter 7 quiz. But otherwise, yeah.
Okay. Thank
All righty.
you. Have a nice day.
Right.
Yeah, you too, man.